So for this function, to find the range of f, I think it takes a little bit of thought. We can see the domain is that x is always greater than or equal to 0. And therefore, with x always positive, then we know that f of x, just looking at that, f of x is always positive. But then have a little bit more consideration as to what this might be doing. One thing that you could do is you could type this into your calculator and then use the calc button and just work out f of 1 would be 12 over 7. F of 10 comes out as 3.529. You could have a look at f of 100, which is 3.95, f of 1000, f of 1 million, and so on, just to see what is happening as x gets very big. And we see this starts tending to 4, basically. It doesn't quite reach 4. And if we have a look at this, we can see that f of x is greater than or equal to 0, but it's also less than 12x over 3x. In our function, 3x plus 4, this denominator, 3x plus 4, is greater than 3x. So if I'm dividing by a greater number, then fx must be smaller than that. Which is 4. So I can see that 4 is an upper bound, and the larger x gets, the more inconsequential that plus 4 gets. If I've got 12 million divided by 3 million and 4, okay, it's slightly less than 4. So actually our range of f is that it is greater than or equal to 0 and it is less than 4. Okay, then we find the inverse function. So to do this, we let y equal our function, 12x over 3x plus 4, and then we have to rearrange this to make x the subject. So if we multiply up by the 3x plus 4, then expand that bracket, 3xy plus 4y equals 12x. I then want to take all of the terms in x over to one side. Let's say, it doesn't matter which side really, 4y is 12x minus 3xy. I want to factorise out the x because I'm trying to make x the subject. And then I'm going to divide by that bracket. And I'll have 4y over 12 minus 3y equals x. And now that tells me that my inverse function is, and then I just replace those y's with x's, 4x over 12 minus 3x. You could plug some numbers in to check. So you could look here and you could say, well, what is f of, let's go back to f of 1. F of 1 would be 12 over 7. If I plugged in inverse f of 12 over 7, probably not the best choice, is 4 times 12 over 7 over 12 minus 3 times 12 over 7, and we could have a look at evaluating that. And that does evaluate to 1, as you'd expect, so we can sort of check that our inverse function works. So when I'm finding my inverse function, remember that the domain and the range switch. So f of x had a domain there, and we found the range above. So my domain for the inverse is the range of my original. So I'm going to do that. And my range is inverse f of x belongs to real and is greater than 0. So next is just a bit of algebra. So we want f of fx. Do not start with what we're trying to show here. Start with what we're given. We're given f of x. So f of fx, we're talking about doing f2 12x over 3x plus 4. So I want 12, let me just write really big, 12x over 3x plus 4. And then in my denominator I've got 3x, so 3 times that big bracket plus 4. Write that in there, 12x over 3x plus 4. It's fine that it looks ugly. What you are demonstrating is that you know the principle of what you are doing here. You're applying f to f of x. So now we need to tidy it up a little. So I can multiply just the top by 12 there, so I'd have 144x over 3x plus 4. And on the denominator here I would have 36x over 3x plus 4. And then I've got this plus 4. I'm going to want to combine these really. So let's leave it like that for now. But what I would then be looking at doing is potentially just times top and bottom of this fraction by 3x plus 4. So if I do that in the numerator, they're going to cancel out. So I would have 144x is my numerator. And then in the denominator, I'm multiplying all of this denominator by 3x plus 4. When I multiply that first term, it will cancel out the denominator of that fraction. So that will give me 36x plus 4 times 3x plus 4. Of course, there are different ways of manipulating this. This I would do 144x over 36x plus 12x plus 16. And keep going, 144x over 48x plus 16. Now looking at what we're trying to find here, what I'm trying to show, I can see that I've got a common factor of 16 on the bottom there. I can take that out. Quick check on the calculator, 9 times 16 is 144. So divide by 16, top and bottom, gives me, or you could even do it really explicitly like this, and then cancel those to show what has been asked. So that's one way of manipulating that algebra to show what's asked. Something that a few of you did that I saw I think you got to maybe this stage here potentially, and you were looking at dividing a fraction by a fraction, so you flipped it. So another way of doing it here, 144x, so there's my 3x plus 4. You need to make the denominator into combine it into a fraction. 36 plus 4 times 3x plus 4 over, sorry, 36x there, over 3x plus 4. And then you're dividing a fraction by a fraction, so you can flip the second one and multiply instead. So if I flip that second one, I get a 3x plus 4 on the top, and we get that 36x plus 12x plus 16 on the bottom, and then that takes us back up to there. We've just shown that f of fx is 9x over 3x plus 1, and we want to show now that that has no solutions, so we would start by putting equal, attempting to solve it and seeing what falls out of that. So if I multiply up by the 2 here, I have 18x, multiply up by the denominator, 7 times 3x plus 1. Expand my bracket, 21x plus 7. Subtract the 18x and subtract the 7. Minus 7x is 3x, minus 7 over 3 equals x. So it appears that I get a solution. But so then I have to have a look at why it's saying I've got no solutions, and a quick look back at the top of the question says f of x is defined for x greater than or equal to 0, therefore f of x also defined for f of x here greater than or equal to 0, which we know it is from the range anyway. So my solution of x being negative 7/3 is not valid. So not valid as f of x is defined for x greater than 0, greater than or equal to 0. Mark schemes on the next slide, so pause if you to have a read through them. And you can see you're awarded the method mark here for this technique, for the technique of letting y equal the function and rearranging. You have to do every single part of that line to get that method mark. So it's not just the let y equals, it's the manipulating it, and it is getting the x terms on one side and other terms on the other. The second method mark then is for factorising and getting x on its own. Okay. And here again you can see the first method mark is simply for showing that you know what f of fx is. So without doing any manipulation at all, just simply writing that down gets you that method mark. Another method mark then for some algebraic manipulation. Okay. And here method mark for solving it, and then accuracy for your conclusions.